Okay, this is a not at STP problem. So this is if we are solving for liters, and it doesn't say at STP. So we're not at standard temperature and pressure. We're at some other temperature and some other pressure that our problem is occurring at. So if we have a not at STP problem, we are going to be using the equation PV equals nRT. Sorry. This is pressure, volume in liters, N stands for number of moles, R is a constant, it is always 0.0. What? Again, this R is a constant, it's 0.0821. That's our ideal gas constant. We always use that for R. And T is temperature in Kelvin. Always need to convert to Kelvin before we can do these problems. So let's look at one of these. This problem says how many grams of zinc must react with excess HCl to produce 40.2 liters of hydrogen at 30 degrees Celsius and 1.25 atmospheres. So the first thing I always do in the problem is I write and balance my equation. This one's already given to me, so I don't have to worry about that. Then I'm going to write what the problem gives me down. So I want to find out how many grams of zinc. So zinc is my X, and it's going to be, my final answer is going to be in grams. Must react with excess HCl. HCl is in excess, so I'm not going to worry about it. To produce 40.2 liters of hydrogen. 40.2 liters of hydrogen at 30 degrees Celsius and 1.25 atmospheres. So I'm solving for X in grams. I start with liters, and I'm not at STP. So I know right away I'm going to need to figure out what my P, V, N, R, and T. My pressure, whenever I see atmospheres, that's my pressure measurement. So my P is going to be equal to 1.25. Volume, I'm looking for something in liters. The problem actually gives me 40.2 liters. That's my volume measurement. Anytime I see liters, it's volume. N is number of moles. I don't have anything I can solve for moles yet. This is going to be what I'm solving for. These problems are either going to give you number of moles or volume to start with. So since I have my volume measurement, I know I'm going to be solving for N. R is that constant, 0.0821. And T is my temperature in Kelvin. So I'm given 30 degrees Celsius. So 30 plus 273 will transfer to Kelvin, and that's going to give me 303 Kelvin. 303 Kelvin. So everything I need out of this paragraph problem is now written down in my workspace. I'm going to scroll down here. I have all my variables written down. Now I want to plug them in to the equation PV equals nRT and write them in like that. This is a good time to pause and try to put the equation together and solve for N by yourself. So go ahead and pause and try to solve for N. And when I come, you can press play and I'll work it out for you. Okay, so I have my problem set up. PV equals nRT with the numbers plugged in. Now I need to solve for N, and this just becomes a basic algebra problem. So what I need to do is I need to get N by itself. So since these are all being multiplied, reverse of multiplication is division. So I'm going to divide by 0.0821 and 303 on both sides. I'm going to divide both sides by those two numbers. What's going to happen is this is going to cancel out. I'm going to be left with just N, and I can plug this whole thing in my calculator, 1.25 times 40.2, all divided by 0.0821 times 303, and I get a total of 2.02 and this is N, so it's moles of H2 is what I just solved for. So I had 40.2 liters of hydrogen gas. I plugged it into PV equals nRT, and I solved for 2.02 moles of hydrogen. I rounded to 3 sig figs. So now that I have moles of hydrogen, 2.02, now I can solve for moles of zinc. And this is where the chart comes in. So I have zinc and hydrogen, 2.02 mole, I don't know, and they're 1 to 1. My coefficients are 1 on both problems, so 2.02 moles of hydrogen are going to be 2.02 moles of zinc. My final answer needs to be in grams of zinc. So all I need to do is take moles, multiply by the molar mass of zinc, which is 65.4 grams per mole. And I'm left with 132 grams as my final answer. 3 sig figs. A lot of work plugging this PV equals nRT in. But once you get that PV equals nRT, then it's just solving like any other stoichiometry problem would be.